Yeah, it looks like it's recorded. Except for I want that thing off the screen. There we go. Okay. So when we're dealing with our parent function, let's go ahead and graph this now. So note that you're only graphing one, so you don't have to do any labels on your graph. Please note the V means vertex. And in an absolute value graph, that's where it actually changes direction, which we'll talk about. But we're going to put our rule here. So that right there goes there. Absolute value of x. And then, so what we're going to do is we're going to put parentheses where we can input values. Our absolute value symbols. This will be the only table we do like this on this whole page. The rest are going to be transformation tables. Okay? We know that the vertex for this is at 0. We should know that from previous. So when our input is 0, we input 0. We get an output of 0. We have an ordered pair of 0, 0. And that allows us to think of our next input being 1. We input 1. The absolute value of 1, the distance from 0 of 1 is 1. So we get 1, 1. And I'm going to input 2. The absolute value of 2 is 2. It's 2 units away from 0, so we get 2, 2. We go the other way. This is negative 1. How far away from 0 is negative 1? It's 1. Okay, so it's negative 1, 1. Notice our graph has now changed directions. Negative 2. How far away from 0 is negative 2? 2. Okay, hopefully that's all review based on what we've done. And we can keep going, right? We can see the trend. Like these points right here. Just keep going. And we add them in. There we go. Kerchow, and good to go. Okay, we use a straight edge because we're cool like that, and we should. We put an arrow because the graph keeps going on forever. Yes, your teacher is picky. They want arrows, or he wants arrows. Okay, there we go. Boom. And booyah, we're good. Bring booyah back, right on. There's our parent function. Good? Okay, now here's the deal. You are going to take, notice this says x inputs, f of x outputs. You are going to utilize that on number 2. You're going to utilize it on number 3. Note this area that says input, output. Why don't you just go ahead and highlight? Don't use a highlighter. Maybe trace it like that with a pencil. Use a highlighter. It bleeds onto the other side, which makes your other side worthless to use there. Okay? And then we turn it over. We have this area. Notice this is an input output. This is unlike the other table of values you've used. No. Oh, here we go again. Another input output. And we go down here. What in the world? We have another input output. Why do I highlight those for you? Because you already have those values. You have them right here. These inputs and these outputs. Your input, when you have negative 2, negative 1, 0, 1, and 2, your outputs are 2, 1, 0, 1, and 2. You're just copying those inputs, outputs. Notice your vertex is still 0, 0 to begin with before we transform the function. You guys with me? Let's go ahead and fill that out over here. This one is negative 2, negative 1, 0, 1, 2. Please stay with me, otherwise you're going to get frustrated here in a minute. This one is 2, 1, 0, 1, 2. Why? Because I'm adding. I'm just going to use these. Now, it changes a little. You might want to use some other values of the parent function. Notice there, like we graph this point, this point, this point. Like we graph those, and then we follow the trend for the other ones. We might want to use some of these other points in our other tables, which the place where we kind of worry about that is when you see fractions, because I want you to use integer values. Okay. Now I said whole number values here, but I meant integers, so you can actually change that. Use integers. Okay. Say rather whole number values. Use integers, since we had that big conversation about that. Integers only. That means whole numbers and its opposites, right? Okay. So note on this one, 1/3, it's inside. Is this a stretch or a shrink? Stretch. That's a horizontal stretch. What are you going to multiply by? By 3. So it's not going to change anything to a fraction. However, when it's outside, this is a vertical shrink by a factor of 1/5, which means I'm multiplying by 1/5, which means I'm probably not going to want to use those values here. We're probably not going to want to use the 0, 0, the 1, 1, the 2, 2, the -1, 1, and the -2, 2. Because what happens when I multiply an output or anything by a fifth, unless it has a denominator of 5 or the number 0, you're going to get a non-integer. Now, I will tell you on this one, which we won't go through today, but as long as someone will ask me for a little help tomorrow, we'll go through questions on it tomorrow. But for now, I'll at least tell you you need to use these values. Is anyone going to ask me for help on this one tomorrow? Like, maybe not even help, just pointers. You're like, hey, McCoy, can you give us some pointers on number 6? Anyone going to volunteer to do that? Okay, 1 or 2 of you. All right. Yeah, maybe tomorrow, though. Ask me tomorrow. Okay. All right, let's go back to here. Why is this different? Well, first, why do I make you do it this way rather than normal table of values? Well, the main reason, well, there's 2 reasons. Really, one is I want you to get used to the transformations and see those and describe them. But the other one is I used to have students just put all this into a graphing calculator like Desmos and not put any thought into it all. They just copy. You become scribes. And if I wanted you to do that, like if I wanted to see if you could copy something, I'd just give you a bunch of paragraphs to write over and over, or math equations to write over and over. That's kind of a waste of time. So what I want to know is if you can think. So, like, what's the transformation here? Tell your neighbor. Okay, so it happens, where does it happen? Inside or outside? Inside. Okay, it happened inside. So does it affect the ins or the outs? The ins, get it? Inside, ins. It affects the inputs. Okay, it affects the ins. Okay, so that means, is there anything on the outside? No, that means we're not going to use this side at all. So you can just kind of scribble that out. Okay, the +3, what did you tell your neighbor? Good. It's a horizontal, let's abbreviate. Horizontal translation. Which way, right or left? It's plus, right? So look at your notes up here. It is left. It's left. How far? 3. That means my parent function should move, this function should move 3 units to the left. Okay? So I'm going to take, and I'm going to change my inputs, only my inputs. Inside only affect the inputs. The outputs aren't going to be affected. They're going to stay. We're going to change the inputs. Rather than having an input, an absolute value here, okay, when I take and I move it to the left, I am subtracting 3 graphically. I'm moving left 3. I'm subtracting 3. So -2 becomes now -5. -1 becomes -4. 0 becomes -3. 1 becomes -2 and -1. So you know my vertex now is at -3, 0. So if you need to, if it helps to write out the ordered pair on this one off to the side, you could do that. That's -3, 0. I'm just looking at the outside, the farthest left column and the farthest right column. That's your ordered pair. So -3, 0 is my vertex. -2, 1. -1, 2. -4, 1. and negative 5, 2. And you can kind of see that pattern again, right? That trend, rising 1 and running 1. Your slope going in and coming out of the vertex is 1 or negative 1. It's absolute value of 1, I guess. Okay, it's right there. So we can continue that out, and we have this, and Kirchhoff, and Kirchhoff. Cool? Right on, man. That makes sense? Yeah. Any questions? Did it move it 3 to the left? Yeah, if we checked our work, everything moved 3 to the left. Okay, let's go to the next one here. Number 3. Tell your neighbor. Does it happen inside or outside? Outside. So it will affect the inside ends or outs? Outs. So there's nothing inside other than X, so we're going to get rid of this. What's the plus 5 do? Is it vertical, or is it translation or stretch shrink? Good. It's a vertical translation. Which way? Up or down? Up 5. Which means we are actually adding 5 to each of the outputs this time. So 2 plus 5. 2 plus 5 is 7. 1 plus 5, 6. 5, 4, 3. It's like we can see the pattern, dude. Oh, that's not right? Yeah, be careful there, right? We actually had a pattern here, but here we go back up because it's affecting outputs. So there's a common error there. We mess up in our table. This is 6. This is 7 because it's going to turn, right? It turns at our vertex, 0, 5. Now, you don't have to list your ordered pair like that every time, but it might help out. Okay? Get 1, 6. 2, 7. And then we've turned, negative 1, 6. Negative 2, 7. Okay. Notice you use the outside columns. How we doing? You guys getting it? Okay, and you have the top filled out. All right, so you can reference back to it. Notice we did go up 5. We translated our parent function up 5 units. Okay, turning it over. I'm not going to do number 4 with you. I am going to give you a start, though. Does it affect inputs or outputs? Inputs, because it's inside, which means we won't use the outputs this time. Okay. Horizontal stretch or shrink? It's a stretch by a factor of 3, meaning you're multiplying by 3. Now, I'm going to be done there. I don't want you to do that one right now. Let's go on to this one. Number 5. Please note your table grew wings. It got bigger. Okay. Are there any inputs that get changed? Anything happening inside? No. So we won't use this at all. Now, I will tell you, you have to have your vertex start at 0, 0 because it says V right there. So we're going to put our vertex there. There are 2 outputs. You won't always use all of them, but there are 2 outputs here. 2 things that are, I'm sorry, there are not 2 outputs, but 2 things that are happening to the output. What's one of them? In? Yeah, it's a vertical shrink BAFO by a factor of 1/5. So we're multiplying by 1/5. Now let me pause there for a minute, because when I multiply by 1/5, When I multiply 0 by 1/5, what do I get? 0. So that's good. But if I were to, don't do this, but if I were to put a 1 there and I multiply 1 by 1/5, what do I get? 1/5, and that's not an integer. Therefore, if I look back at my parent function, which is right here, what number is divisible by 1/5 or by 5? 5. And what else? 10. So if I look at 5, if I want an output of 5 and I want an output of 10, then that would mean I'd have to go to my output, which is right here at 5. That's my y value. That's an output value. And follow it over to my graph. What's my actual input? 5. And what else is my input? 5 and -5. And same thing with 10. It's 10 and -10. Okay, so I can use 5 and -5 and 10 and -10. And that then allows me to get my 5 and 10, but now I can multiply by something like a 1/5 and get an integer here. What's the negative do? Yeah.
Reflection of the x-axis.
Yeah, this is a reflection in x-axis. And really that just flips all your signs. Okay, it's like multiplying by -1. It just changes the sign. So for instance, if I get 1 here, right, because I multiply 5 by 1/5, I get 1, then I change the sign, it becomes -1. This stays 0. Okay, so I get the ordered pair 0, 0, and 5, -1. Right, that and that. Now I'm going to pause right there. Tomorrow we'll talk about this one, if you ask for help. Any questions?